If you're sitting down to watch this whole playlist at one time, I suggest taking a break right now because now we're going to look at logarithmic equations, which is similar to what we just did, just going in reverse. But again, it might be a good idea for you to pause, try some of the questions in Alex dealing with solving exponential equations before you move on to doing the same thing in reverse. So notice that I have broken this into method 1, method 2, method 3, just like I did for exponential equations. And the only difference here is we have to watch out for values that make the expression negative because I can't take the log of a -2 because remember the domain is only values that are positive. So if you get a 0 or a negative, we got a problem. So make sure you check that when you're done. That's the only thing different than what we did before. So again, because I have a base of 5, what I'm going to do is instead of take the log of each side, I'm going to exponentiate each side. And that's just a fancy term for take whatever your base is and make that the base. So I'm taking 5 to the log base 5 of 3x and 5 to the log base 5 of 7x minus 16. Now what does that do for me? Just like before, my 3x is going to pop out front. The 5, log base 5, those things cancel. And so, essentially turn into 1. So it's just 1. So it really goes away. Same thing here, 5, log base 5, I get 7x minus 16. Now it's just an easy equation that I can solve. Oops, 7x minus 16. I would subtract 7x from each side. I would divide each side by -4 to get +4, and my answer is positive. 3 times 4 would be positive. If I plugged it in here, it's positive, so no problems. Same thing on the other one. Again, you can press pause and try that question on your own. But remember, the base of a natural log function is e. So here, instead of taking the base of 5, like I did before, I'm taking a base of e to the natural log of 2x minus 1. That looks like a weird 2x minus 1. And then e to the natural log of 5x minus 13. So again, method 1 is when both sides have logarithms of the same base. It's the simplest one. E and natural log, those things really cancel because it's e, and then natural log, which is a base e. So these guys just become, my exponents become, terms. 2x minus 1 equals 5x minus 13, and I can solve this. Let's subtract 5x from each side. Negative 3x minus 1 equals negative 13. Let's add 1 to each side, so negative 3x equals negative 12. Divide, oh look, I got 4 again. And again, don't just look to see if 4 is positive. When I plug it back in, is this positive? Yes. Is this positive? Yes. That's what you have to check. Method 2 actually I think is easier than method 1 because again I can do it 2 ways and I'll show you both ways. The first way is just like I did the last one, 4 to the log base 4 of 2x equals 4 to the third. So I'm still exponentiating each side. And when I do that, I get 2x equals 4 to the third is 64. Divide by 2, I get x equals, whoops, not 8, I was taking the square root, x equals 32. So that one was pretty painless. The other way to do it, I think, is way more fun because it just takes us back to that swirly method. The swirly method says you get 4 to the third equals 2x, which, if you'll notice, is exactly what I had before. So 64 equals 2x, and then x equals 32. So I got the same answer either way. I typically swirl it, but either way you do it, you get the same answer. So again, the second one you can try on your own, or you can do it with me. Before I do anything else here, I have to get this by itself, so don't go ahead and try to swirl until you get that 4 out of the way. So I'm going to subtract 4 from each side, which gives me the natural log of 5x equals 0. And then again I'm going to swirl, so e to the 0 equals 5x. And e to the 0, just like anything to the 0, is 1. So I have 1 equals 5x, which means when I divide each side, I get 1/5. And again, that works great because this value is positive when I plug it back in. So method 3 is actually exactly like method 1, except that when I'm done, I end up with a quadratic, which is why I made it its own method. There's actually one more method, and I don't think I've created a slide for that because I don't know that I've given you that question in ALEX. But the last method would be if I had a log on each side, like I do here, and then say a 3 plus log base 3 of 2x plus 4. And I don't think I've given you those, but again, I would do it exactly like this. I would just end up with another constant. So it really wouldn't change things beyond what I would do here. Just like I'm going to do down here, I'm going to take 3 to the power of all of these. And so the only difference is I would end up with a 9 plus all of this and whatever on this side. So it really wouldn't change things. So if you get a question like that in ALEX, don't think I haven't gone through it with you. It's exactly like this method. I'm just going to end up with another constant to simplify. So again, let's look at this one. We have log base 3 on each side, so I'm going to take 3 to the log base 3 of x squared plus 5, and 3 to the log base 3 of 2x plus 4. And those things cancel, and those exponents come out to the front, so I get x squared plus 5 equals 2x plus 4. And again, going back to this question, I would have those same things here, but I would still have that plus 9, and I would just have to deal with that. So again, because it's a quadratic, that means everything comes to one side equal to 0. So I would get x squared, I would subtract the 2x from each side, I would subtract the 4 from each side. So this is what I'm left with. I'm trying to solve that. Whereas if I had that plus 9 in there, it would be x squared minus 2x. And then I would have, instead of plus 1, I would subtract 9 from that. So I would have minus 8. So I would be dealing with just a different equation, but doing it the same way. It's a quadratic. I can factor. If I won't factor, I can use the quadratic formula or any of the other methods we learned. I'm going to factor this, look for numbers that multiply to positive 1 that have a sum of negative 2, and that's negative 1 and negative 1. Or, of course, I could write x minus 1 quantity squared equals 0. I'm worried about the solution, and so the solution is when I take x minus 1 and set it equal to 0, adding 1, I get x is 1. Always double check to say if I plugged 1 in, would these be positive? The answer is yes, so my answer is 1. So now let's look at our next question. Same idea, and again, looking up here, this would be x minus 4, x plus 2 equals 0. I would get the two answers. Make sure that when you plug in the answer, you end up with positive results. My answer of x equals 4 would work just fine. My answer of x equals negative 2 would not work just fine. So, bad. Let's go ahead and take a look at the second equation where we'll really go into more depth on what happens when we have that negative. So I'm going to take e to the natural log because, again, natural log has a base of e. X squared plus 3x, and then e natural log 5x plus 8. These guys go away. That gives me x squared plus 3x equals 5x plus 8. I'm trying to get x squared, or I'm sorry, everything all to one side of my equation. So x squared, I'm going to subtract 5x, so that's negative 2x. I'm going to subtract 8. And now I have it equal to 0. And gosh, it looks exactly the same as what happened up here. So we already know how to factor. Numbers that multiply to negative 8 that have a difference of negative 2 would be x minus 4, x plus 2. I would set each of those equal to 0. And I would get x is positive 4, x is negative 2. If I plug in a positive 4, that's positive, that's positive. If I plug in a negative 2, this guy would be 4 plus 3 times negative 2 is negative 6. So I'd be taking the natural log of negative 2, and that's no good. And so negative 2 would not be an answer, and my only solution would be 4. So again, if you're feeling like you already understand how to do this, skip ahead a few minutes. I still have a couple of slides left in this video. Otherwise, let's do some questions to practice and make sure you know what you're doing. So press pause, try these questions, then press play to see how you did. Again, this is a base of 6, so I'm just going to exponentiate with 6 as the base, and we all know what happens then. The 6 and log base 6 are inverses of one another. Because they're inverses, they're essentially going to just go away. Just like when we add 5 and subtract 5, it's like we didn't do anything. Then I get x plus 2 equals 2x plus 7. I just have x to the first, so let's just get x by itself. Subtract x from each side. Add 7 to each side. 9 equals x. Double check. Yep, that would make it positive. Yep, that would make it positive. For 2, again, I'm just going to swirl this one. 5 to the third equals 2x minus 1. And again, it's because the 2x minus 1 is in parentheses that I can do that. This side's 125 equals 2x minus 1. Let's add 1 to get 2x by itself. Let's divide by 2 to get x by itself and get, 63 as my answer. Again, would that make the expression positive? Yes, it would. Let's try question 3. Question 3, like question 1, except the base is e. So it's e to the natural log of x squared equals e to the natural log of 2x plus 15. Again, these guys are inverses, so I just end up with x squared equals 2x plus 15. This one is different than the first because I've got an x squared, so it's a quadratic. So instead of getting x by itself, I get everything to one side equal to 0. From here, let's factor. What numbers multiply to 15, negative 15, that have a difference of negative 2? That would be, negative 5 and positive 3, which means if I set x minus 5 equal to 0, I get positive 5. If I set x plus 3 equal to 0, I get negative 3. Now, a lot of times we get concerned when we have an answer like negative 3, but this would be x squared, which would be positive 9. This would be negative 6 plus 15, which is positive 9. So this guy works, as does this one. So I actually have 2 answers for that one. For my last one, I would subtract 6 from each side first. That would give me natural log of x minus 1 equals 0. I'm just going to swirl this one like I did question 2. So e to the 0 equals x minus 1, because remember the base is e. E to the 0, just like anything, is 1. So I'm going to add 1 to get 2 equals x. And again, 2 minus 1 is 1, so we're okay. So that's my final answer. I wanted to show you what happens sort of putting all together everything that we've learned in a question like this. It's the same concept that we did before, but if you'll notice, I've got 2 natural log functions on one side. So this is where that expanding or condensing will come into play. So I'm going to rewrite this. This side's going to stay exactly the same, but because this is a minus in between, I'm going to rewrite that as natural log of 10 divided by x. And so again, I used that simplification because there was a minus in between to write it as a quotient. That's the quotient rule. And now I can take e to the natural log of x plus 3 and take e to the natural log of 10 over x. So that gives me x plus 3 on the left, and it gives me 10 over x on the right. And we've probably done a question like this, but it's been a while. I don't like to have that x on the bottom, so I'm going to take everything times x so that I don't have to deal with a fraction. That's going to give me x squared plus 3x, and on this side I'll have equal to 10. So now it's pretty straightforward. We should be really good or comfortable with solving quadratics at this point in our lives. So I have x squared plus 3x minus 10 equals 0. This will factor into x plus 5, x minus 2, because that would multiply to negative 10 and combine to 3, which means x is, sorry, let me rewrite the whole thing. X plus 5 is equal to 0, so x is negative 5. And x minus 2 is equal to 0, so x is positive 2. Again, I need those answers to be positive, so if I plug in a negative 5 here, I would end up with a negative, so this guy is not going to work. If I plugged in positive 2, I would get 2 plus 3, that's 5. The other one, 10 divided by 2 is 5, so my only answer is x equals 2.